These graphs show how the vapour pressures of two components A and B in a liquid mixture vary according to the composition of the mixture. This first graph represents an ideal mixture which obeys Raoult's law. It's a straight line relationship and the total vapour pressure is directly proportional to the mole fraction of A or B in the mixture. This ideal behaviour only happens when the interactions between a molecule of A and a molecule of B are no different in strength from the interactions in the pure liquids. For very similar liquids like hexane and heptane, this can be almost true, but most mixtures are non-ideal. They show deviations from Raoult's law. The commonest kind of deviation is shown in the second diagram, which is figure 17.22. In this type of behaviour, the molecular interactions between A and B are weaker than the interactions in the pure liquids. Molecules of B disrupt the interactions between molecules of A and vice versa, so that molecules of both A and B can escape more easily into the vapour phase. As a result, the vapour pressures of both A and B are more positive than Raoult's law would predict, and so is the total vapour pressure. This kind of mixture is said to display positive deviations from Raoult's law. For example, mixtures of propanone and carbon disulfide show this kind of behaviour. Negative deviations from Raoult's law are illustrated in figure 17.23. In this kind of behaviour, the molecular interactions between A and B are stronger than the interactions in the pure liquids. Molecules of A and B attract each other more strongly than they attract themselves, so they escape less easily into the vapour phase. As a result, the vapour pressures of both A and B and the total vapour pressure are more negative than Raoult's law would predict. This kind of mixture is said to display negative deviations from Raoult's law. Mixtures of propanone and trichloromethane show this kind of behaviour, because these two molecules form hydrogen bonds between one another which do not form in the pure liquids. Raoult's law is deviated from far more often than it's obeyed, but these deviations provide useful insights into the interactions between molecules.